Let's find out what is remainder theorem. Now earlier we have seen that when we divide a polynomial px by another polynomial gx, we know that we get a quotient, which we typically represent the quotient polynomial as qx, and we also get a remainder polynomial that we represent by rx. So q for quotient, r for remainder. And earlier we have seen in detail the step-by-step way of doing these long divisions. The remainder theorem tells us that without doing the actual long division, we can simply find out the remainder. Again, let me say this one more time. Remainder theorem tells us that without doing the long division, we can very simply find out the remainder. So let's take a look at what is the remainder theorem. So the remainder theorem states that let px be any polynomial of any degree greater than or equal to 1, and let's say a is any real number. Now, when we divide, if we divide px by the linear polynomial x minus a, then the remainder is given by p of a. That means the value of polynomial at x equals a. So in other words, if we have any polynomial px and we want to divide this by x minus a, where a is a real number, if we do this division, then remainder theorem is telling us that we will see a remainder will be simply the value of this polynomial at a. So this is amazing, right? It is so easy to find out a value of a polynomial at a particular value of the variable, and it is relatively harder to do these long divisions. So if this is indeed true, this will be a tremendous help in finding out the remainders very, very quickly. Now, right now, we are not going to go into the detail of the proof of this theorem, but we will take a look at a few examples and validate for ourselves if this is indeed true. So let's say, let's take our polynomial, dividend polynomial as, let's take maybe a linear polynomial, then we take a quadratic polynomial, and we'll take a cubic polynomial. So why don't we take our first polynomial as maybe 5x plus, let's say 8. So we want to find out, we want to divide this by, let's say, our polynomial that we want to divide it by is simply x minus 1. So we want to divide px by gx and see what the remainder is. The remainder theorem is telling us, well, this is in the form x minus a, so a equals 1. So remainder theorem is saying simply find the value of polynomial at 1, and that should give us the remainder. So let's find out the value. We know how to find out value of a polynomial at a particular value of the variable. So let's see what we get here. So we see that this will be 5 plus 8, or simply 13. So the remainder theorem is saying when we actually do this division, our remainder should be 13. Now let's check it for ourselves. So let's do this division quickly. So we will have 5x plus 8 over here, and we have x minus 1. So the first term will be 5x divided by x. So the quotient will be 5 here, the first term. So 5 times x is 5x. 5 times minus 1 is minus 5. And now when we subtract it, the signs, they reverse. So this cancel out. 8 plus 5 is 13. So indeed, we see that this is our quotient and this is a remainder. And the remainder theorem has already pointed out what the remainder will be. So indeed, it works. In the next example, we will take a quadratic polynomial for px. Here, this was a linear polynomial. Next, we will take a quadratic polynomial. So let's say we take px as, we want to take a quadratic polynomial, maybe 2x squared minus 5x plus 3. Let's say this is our quadratic polynomial, and we want to divide this by gx, where gx is, let's say, x minus 2. So remainder theorem is saying that when you actually do this division, the remainder will be simply x minus a. So a will be equal to 2, right? So if you find out the value of this polynomial at x equals 2, that should give us the remainder. That's what remainder theorem is telling us. So let's find out. So instead of x, we put 2 here. So this 2 squared minus 5, 2 over here, plus 3. Or we get 2 squared, 4 times 2 is 8. 8 minus this will be 10, plus 3. So 8 plus 3, 11 minus 10, 1. So the remainder theorem is saying that when we do this division, our remainder should be 1. So let's check it for ourselves. Let's actually do the division over here. So we have 2x squared minus 5x plus 3. Let's divide this. Let's divide this by x minus 2. So the first term will be 2x squared divided by x, or simply 2x. So when we multiply 2x and x, we get 2x squared. We multiply 2x and minus 2, we get minus 4x. Right? So if we subtract, so these signs, they reverse. So this cancel out. So plus 5, minus 5 plus 4 is minus x. And then we have plus 3. Now we take minus x, divide by x, we get minus 1. So when we multiply this, we get minus x, and minus 1 times minus 2 is plus 2. Now when we subtract, the sign, they change. So this cancel out, 3 minus 2 is 1. So again, now we see the remainder as 1, but our remainder theorem had already told us that the remainder will be 1. So this is really fascinating. In the next example now, let's take a cubic polynomial for px. Now earlier, when we were actually doing the long divisions, we had seen this example. We had done the long division where px is this expression, or we should say this polynomial, and we divided that by the polynomial x minus 4. And we saw our remainder was this. Now let's use the remainder theorem and see if our answer was correct. So the remainder theorem is saying simply, if you find out the value of this polynomial at x equals 4, then that should give us the remainder. In other words, our remainder should be this. So let's find out the value of this polynomial at x equals 4. So we have 4 cubed plus we have 2 times 4 squared, x squared, plus 3 times x, or 3 times 4 plus 5. Right? So this should be 4 times 4, 16 times 4, 64. This is 64. 4 times 4, 16 times 2 is 32. Plus this will be 12. And this will be 5. Or in other words, we have 64 plus 32 plus 17. So let's do this over here. 64 plus 32 plus 17 is simply, so 6 plus 7, 13, 1 carry over, 6, 7, 8, 9, 10, 11. So when we do this addition, we see we get 1, 1, 3. So the remainder theorem is saying the remainder should be 1, 1, 3. And when we had done the long division, we had indeed seen that the remainder was 1, 1, 3. So it is fascinating how the remainder theorem can so easily tell us what is the remainder when we divide any polynomial by a linear polynomial. So very quickly, we want to just go over some of the highlights. Remainder theorem is tremendous. It is a tremendous help in finding out the remainder without actually doing the long division. We would also want to note that the remainder theorem works only when the denominator or the divisor polynomial is a linear polynomial. In other words, if we had any polynomial and we wanted to divide this by, let's say, x squared plus 2x minus 1, can we apply the remainder theorem? We cannot, because this is not a linear polynomial. This is a quadratic polynomial. So the denominator, it has to be a linear polynomial. And finally, we want to note that the remainder theorem, it does not tell us anything about the quotient. Remainder theorem helps us find out the remainder of a polynomial division without actually doing the division.